Hi everyone, today we're going to be looking at the Physics Aptitude Test. I believe it's called the Physics Admissions Test nowadays. This is the 17th question and it belongs to the 2019 exam for the University of Oxford. So let's get right into it. Find an expression for the angle theta for which the gray area AG is f times the area of the outer square AS. Your expression for theta should take the form theta equals b minus cf x squared over x squared minus 1, where b is a constant and cf is a function of f. State b and cf explicitly. You may assume that, okay, the value of xr indicates the radius of the outer circle. So this is important to us because it means that this place that we have here is going to be xr, 2xr, sorry, because the radius that we have is xr. And this would basically mean that because the outer square's area is AS, this is going to mean 2xr times 2xr is going to be our area for the outer square that we have. And then inside we have a circle. It's not completely a circle because as you can see here, we have a sector that separates between these two lines of the circle, 2 points of the circle. And there are many ways to go about this question. Today I'm going to show you just one, and as I've said, there are numerous ways you can go about and explore this question. But what I'm going to do is this area right here, as you can see, this is one sector. This, the remaining part, is the other sector. So because this is 2 pi, when I subtract theta from 2 pi, this gives me the remaining angle of the remaining sector that I have here, the white one. So by using the area of a sector formula, I can find the area of the white sector that we have here. So in order to find the area of a sector, it's going to be 1 over 2 times theta times r squared, where theta is the angle of the sector. So what we can do here is, when we're trying to calculate the area of the white sector, we can do 1 over 2, 2 pi minus theta, and then xr squared, because our circle here has a radius of xr. That means when we're calculating the area of the sector, we're going to use xr. But we're not done here. We have another sector here that we have to calculate in order to remove from this white one that we have here. So I'm just going to do minus 1 over 2, same as before, 2 pi minus theta, and then times r squared this time because we have r here. So this is the area of the white area that we have here. And then this can be revised to seem like this. This is the area of the white piece that we have here. If I remove the area of the white piece from the area of the square, which we had found here, what I'm going to find of 4x squared r squared, what I'm going to find is the area of the gray piece that we have here, which is the combination of all the gray spaces that we have here. So if we just do that and proceed with the equation, we're going to get this when we leave theta alone. So let's go ahead and do that. So I'm going to be removing AS. So I'm going to be removing the white piece from the area of the square, and I'm going to be left with the gray area. So that means 4x squared r squared minus 1 over 2, 2 pi minus theta r squared, x squared minus 1 is going to give us the area of the gray area, which we had found to be f times the area of the outer square AS. So what this means essentially is, let me show it here. If I multiply f with the area of the square, I'm going to get the gray area. This is what the question tells us. So that means the area of the gray area is going to equal 4x squared r squared times f. We have derived this from something that question tells us. So what's left to do is to just arrange the equation so that the theta that we have is left alone. So I'm just going to do that right now. R squared x squared minus 1 over 2. And we can also write this as 8x squared r squared over 2 equals 4x squared r squared f. This is just going to be equal to 8x squared r squared minus 2 pi r squared theta r squared times x squared minus 1 equals, when I throw the 2 to the other side, 8x squared r squared f. Rearranging again, 8x squared r squared minus 2 pi r squared x squared minus 2 pi r squared, and then theta r squared x squared plus theta r squared. And if I just continue from here, it's going to be 8x squared r squared. This is equal to 8x squared r squared f, by the way. If I continue on from here, it's going to be minus 2 pi r squared x squared. And we can also arrange this so that it's written as x squared minus 1. I've just arranged this piece here. And then plus theta r squared x squared, then minus theta r squared is what we're left with, which equals 8x squared r squared f. So one thing that should be realized here is, in order to leave theta alone, we can get rid of one common thing that exists in both sides of the equation, which is going to be r. If I remove r from all sides of the equation, we're going to be left with 8x squared minus 2 pi x squared minus 1 plus theta x squared minus theta is going to be equal to 8x squared f. And our aim was to leave theta alone from the first place, so we're going to be left with theta x squared minus 1 equals, I'm just going to throw everything to the other side, 8x squared f minus 8x squared plus 2 pi x squared minus 1. So this is what we're left with right now. And of course, to leave theta alone, I'm going to divide everything by x squared minus 1. And as you can see here, this is something that's common in both of them. So if I just divide them, it's going to be 2 pi plus. I'm going to be dividing this part, 8x squared f minus 8x squared, with x squared minus 1. This is going to be equal to 2 pi plus, something that we can do here is to take both sides into a common factor, and f minus 1. This is what we're going to be left with. So we should look at what we were supposed to find, the notation that we were supposed to find at the beginning of this question. And by looking at this here, we can say that b is 2 pi. So because the question wanted us to state b and cf explicitly, we're doing just that. This was 2 pi, okay. And also here we should find x squared minus 1. We have found that too. And when we look at this, we can also find cf times x squared. We have found 2 pi plus x squared times 8 f minus 1 over x squared minus 1. So this checks out too. But we were supposed to find a minus here. So one way to fix that is going to be 2 pi minus, I'm just going to reverse this part and say 8 times 1 minus f, and x squared stays the same way. I'm going to say x squared minus 1 again. So from here you can see that CF, the function of CF that we were supposed to find, is going to be 8 times 1 minus f. And this equals 2 pi minus CF x squared over x squared minus 1. CF being 8 times 1 minus f. And this gives us the equation that we should have found here. The part B of this question says find a numerical value for theta to 5 significant figures when x equals 3 and f equals 1 minus 2. I'm not going to do this part. This is just putting the numbers in the required places and getting the result. And we have to be careful with the 5 significant figures here, but this is basically how you can attempt to solve this question. I think one of the most important things in these kinds of questions is if you're sure of what you're going to do, and it's probably going to take a long time, you shouldn't stop somewhere in the question and try to turn back and say, what if I have done it wrong? This is taking too long, because as you can see, the calculations in these kinds of questions take a long time, but in the end, you do find the results. So it is important to manage your time efficiently and to keep going without forgetting what was asked to you in the question. But this is all for today. If you have any other questions for this explanation, I'm always welcome to answer them. Thank you, and I hope you have a nice day.